Let's see it. Let me find SPSS. Okay, don't need that. I'm going to start a new data file. Okay, now in SPSS, I'm going to define some data set here. I'm going to say my first variable is going to be frequency. My second variable is going to be gender. And my third variable is going to be whether or not the person had was caused by Campylobacter, that particular organism.
Campylobacter, yes.
Okay. Now these, I'm going to make these nominal variables, the gender and campy. In other words, and then I'm going to label them. I'm going to say that the value 0 represents that
Male,
gender was male,
male, yes.
and 1 represents female. Okay? And then I'm going to go over to campy, and I'm going to say, let's see, for campy causing illness, being the cause of the illness, I'm going to say 0 is campy caused it, and 1 means that not campy.
Not campy, some other bacteria.
Some other organism, right? Okay, good. So now I'm going to go back to my data view now. Okay, and in my data view, I'm going to say, okay, let's see what my possible things are going to be. I could be male, right? I could be male. I could be female. I could be female. Oops, I picked the wrong one. I could be female. I could be female, a male who was infected with campy. I could be a male who was infected with something else, right? I could be a female who was infected with campy, 0. I could be a female who was infected with something else,
Okay.
right? So now in the
Yeah.
frequency now, I have to put these values that I have. Okay, so how many males had campy? Males with campy is 1724.
Yes.
Right? Tricky, right? It's a little tricky. Males without campy is, I got it obscured there a little bit, 1958.
90, yes.
Okay?
1958.
Now, females with campy is 1531.
1531.
And females without campy is 2004. Those are all my observed values. Now, I can go into this and say, I'm going to data and say weight cases. Okay? And I can say weight the cases by frequency. Okay, click OK. Now what SPSS will do from now on is when I do my data analyses, it will do it as if I had 7,000 individual cases. So I can actually go up here and say analyze descriptive statistics crosstabs. And I can say, okay, my rows, my exposure is my gender. My outcome is whether or not they had campy. And I can ask it, well, show me my chi-square value. And in the cells, just show me the observed values. And I'll click OK. And SPSS actually does that for us. See, it built the table for us just like we wanted. It calculated chi-square for us and the probability that these differences could be due to chance instead of to, and look, I can give you a little bit of a heads up here. Look, our chi-square value is a pretty big number, 8.9, and the probability that we'd be wrong if we reject the null hypothesis, the significance or p-value is less than 0.05, so we know we're going to wind up rejecting the null hypothesis. Not only that, now I can go back, I can analyze, I can go back into descriptive statistics crosstabs, and I can also ask it to do all sorts of other things for me. I could ask it to calculate the expected values. I could ask for it to calculate the percentages by rows. I could ask for it to do a risk analysis.
The risk.
Click that. I'm going to click OK. Okay, and SPSS will do all sorts of other calculations for us. See, this was our observed values. It calculated, remember 1660, that's the same thing we got when we
Yes.
started to
Yeah.
calculate the expected count, right? It does that for all 40s. It found that 46% of the male foodborne illness was due to campy, where
Camping.
43% of the
Camping.
female illness was due to camping. So your relative risk is 46 over 43, or about, looks like about 1.1, roughly 1.1. So you're about 10%, males are 10% more likely to be infected with campy than females are if they have foodborne illness. And if you go down here, you get your chi-square calculated again. If you go down here, here's
Yes.
your odds ratio and your relative risk, 1.08.
It's
You're again 8% or almost 10% more likely to be infected by campy if you're a male than if you're a female. And the odds ratio also says that. And it also calculates confidence interval. In other words, if there's no difference between the rate that males and females, or the odds or relative risk for males and females, then the relative risk or the odds ratio would be equal to 1. Well, in fact, it's telling us that we're 95. I'm going to run out of power. We're 95% sure that the real risk is between 1.05 and 1.2 and odds ratio, and the real relative risk is between 1.02 and 1.1. One is not within that interval, so we're 95% certain that you could reject the null hypothesis that there's no difference in the odds for what you're infected with if you're male or female. So does that make sense to you?
Yes, it does. My major problem was inputting the data into the
Oh,
SPSS,
so this should
and
help a bit,
also
right?
yes.
Okay, what I'm going to do is I'm running out of power, so I'm going to have to log off soon. What I'm going to do is I've been recording at least part of this. I'm going to email you the recording,
Okay.
okay? And I'm going to email you the files that I just created, so you can use them as a
Okay.
start for your work.
Okay.
Will that help?
Okay. Thank you. Thank you so much. Very
No
helpful.
problem.
Thank you.
No problem. It's pretty
Yeah.
interesting. You know, foodborne illness in general, I think it's. I don't know, for some reason, I find it kind of fascinating. You may have noticed that during the semester I brought it up a couple of times. You know, when with in terms of like some examples that we were playing with, and they use this kind of
Yes.
analysis quite a bit when they go in and try and track down, you know, like when they had that outbreak, the various outbreaks during the summer associated with, I think one of them was scallions, another one was like
Yeah.
lettuce
The
or something
produce.
like
Yeah.
that. So, and they were trying to
Yes.
determine, you know, of all the things that these people ate, which ones were the ones that actually put them at risk for, you know, whatever the E. coli or whatever was the particular issue at that time. You know, so it really is, you know, the foodborne illness is all by itself is a pretty interesting thing to study. All right, so I'm gonna save the files, email them to you, and I'll also save the
Uh,
recording so you get a chance to go through it and maybe kind of reproduce it yourself.
okay. And also, my last question is, I would like to do the calculation, the raw one, and also do the software calculation for both of them. Is that okay, or you just need one of them?
Well, it should come out the same, but if you want, you can use SPSS. You remember, just like this, you could use Excel to do these calculations. For instance, if you wanted to calculate the risk for males of being infected with CAMPy, it's going to be equal to 1724 over 3682, right? And if you wanted to calculate
Yes.
the risk for females, it would be equal to 1531 over
To-
3535, right? So our relative
Yes.
risk is going to be equal to the risk for males divided by the risk for females,
That's
will
for
equal
yes.
1.08. How about odds ratio? The odds for males is going to be equal to 1724 over 1958, okay?
1958. Yes.
And the odds for female,
Yeah. 1531 over 2004.
yeah,
2004.
there's a reason why I'm going to do this now. Hang on a second, just because I want to demonstrate something to you. And the odds ratio is going to be equal to this divided by the odds for female is going to be equal to 1.15. 1.08 and 1.15. Let's take a look back at our output from SPSS. 1.08 and 1.15. Same values they got there, right? The
Yeah.
advantage that you have with
Yes.
SPSS is it also calculates for you something that's a little bit
The
more
confidence.
complicated, the confidence interval as well as just the value itself. Okay, but certainly
Okay.
you could do these calculations manually that way yourself. You could also do chi-square yourself. The observed values minus the expected values squared divided by the expected values. The observed value minus expected value squared divided by the expected value, and add them all together and get that same chi-square value. Okay, so certainly you
Okay. I'll
could.
do them both.
I'm sorry.
I said I'll do them both. I'll do both of them to give me, you know, yeah, I'll do the software as well as the manual
Okay.
calculations.
Okay. Good. Good. I think it's a good exercise. I really do. All right. Good.
Yes.
Good luck on
Yes.
it. And
Thank
I'll
you.
email this to you by tomorrow morning. And if you have any issues with it or something like that, send me an email back. Okay.
Okay. Thank you so much.
No, no problem. Have a good night. And if I don't speak to you again, have a good holiday. Eh?
Thank you. Thank you, Prof. Thank you.
Bye.
Bye bye.